Okay, so here we're going to go through the creative coding with ChatGPT Workshop. First up, why do we teach coding at all? So learning how to code allows you to give instructions to a computer and to solve problems that would be either difficult or impossible to solve all on your own. And the better that you are at coding, the more flexible of a problem solver you can become, and it will allow you to extend your own human abilities and interact with the digital world in a new way. We also want to increase the diversity of people who can get involved with computers and technology. So, learning how to code has a reputation for being an extremely difficult and intimidating process, and many people count themselves out because they don't think they fit the image of who a coder is. Personally, I've always struggled with math. I have something called dyscalculia. It's like dyslexia for math. And because of this, I was really bad at algebra. And I thought that because of that, I could never be a coder. This is something that I couldn't possibly ever do. And it wasn't until my grade 11 year when I had a math teacher who encouraged me to try out coding in a playful and exploratory way using a similar program to what I'm going to show you today. Um, it wasn't until him that I actually got good at coding and really realized that this was something that I could do and started thinking of code as a creative and artistic process as well as a mathematical one. So um, it's really important that we can bring code to people in a way that is playful, is exploratory, meets them where they're at, because then a lot of people can try it for themselves and decide for themselves if coding is something that they want to pursue or not, um, just so we get out of that people being told that they can't do it or think that they don't fit the image. So I really think that it doesn't matter who you are or where you come from, anyone can learn how to code. Finally, coding is a really great way of teaching general problem solving skills. A lot of the strategies that you use when trying to solve a coding problem can be generalized to nearly any type of problem solving. And because computers give you such fast feedback on whether or not your solution and your approach worked, it's a great way to train those problem solving skills because you have this fast feedback loop. So, when we teach coding, what is it that we're actually trying to teach? So, one answer to this could be that we are teaching students to write code. But the problem here is that there are so many different coding languages that we could choose to teach, and there are new languages coming out all the time. So, it's just not possible to teach someone every coding language that they might need to know. And having this perception puts a lot of burdens on teachers and scares teachers away from bringing coding concepts into their class because they think that if they don't know a bunch of code languages and they don't know how to code very well themselves, then they're not going to be equipped to deal with all the student questions. But the secret here is that the actual language that we use to teach doesn't matter because we're not trying to teach how to write code. We're trying to teach something else. There's this more general skill of computational thinking. I like to define this as a type of problem solving which involves expressing problems and solutions in terms which can be understood and executed by a computer. More generally, it's learning how to speak and to understand a computer. So, what are the steps that go into computational thinking? So, there are broadly four steps. Generally, you'll start at step number one and end at step number four, but it doesn't always go in order. You'll bounce around a little bit. Step one broadly involves decomposition. So when you first encounter a problem, oftentimes this problem is going to be too big for you to solve in one single step. And so what you need to do is break this problem down into pieces. What are the smaller problems that you can start with when you are trying to solve this bigger problem? You need to break it down into pieces until they get small enough that you know how to solve them. Next, there's the more general skill of pattern recognition, just recognizing that there is patterns, what are the similarities and differences of different parts, and asking if there are any steps that are repeated. Then we have abstraction. This one's a little bit hard to get at first, but it's asking what are the essential and important details of this problem. Is there a more general version of this problem that I've seen? Have I seen other similar problems to this one before? So it's really asking to figure out what are the important parts of this problem. We see this in math problems a lot, you might have come across in grade school the problem something like Susie has two apples and then gets two more of them. Also, she likes to go fishing on the weekends. How many apples does Susie have? Right? Some of this information is relevant to solving the problem and some of it is not. So the skill of abstraction is figuring out what are the pieces of this that are relevant. Finally, we have algorithm design. So this is taking the abstractions, taking these patterns, and turning them into concrete instructions that a computer can understand. And the instructions that you give are going to be specific to the language that you are working with. So you'll give different instructions if you're working in something like Python and JavaScript and C++. They're all a little bit different. And this is where people tend to focus and tend to get scared, is because there's so many different ways of writing these instructions and it can get really complicated and there's a bunch of special symbols and things that you have to use and the computer can get really picky. So people get hung up on this step, but really it's only the last part of the last step. Even before you go and start trying to write the code, you have to have an idea of what are the steps that you need to take to solve this problem. And being able to state those in just common natural language is actually more important than knowing what code specifically to write, especially with the rise of language models, which we're going to be touching on in just a little bit. So, what's a good way of teaching this type of skill? I'm personally a fan of creative coding. So this is just the general idea of taking the computer screen and treating it like a canvas, treating it like a blank paint canvas. And there's a program that allows to do this, which we'll get into a second. But these are just some examples of the types of things that you're able to make. Is really treating it almost like an abstract art piece. Because this allows people to express their creativity. You can start making little games, little animations. And there's not really a wrong answer here. The goal is just to experiment and just to see what types of shapes and colors and things you can create. On the right of this screen here, this is really interesting because we can actually see how this can be taken beyond just a two-dimensional screen, and you can actually start taking in data about the world. So this is how video games work, is that you'll use some kind of motion capture software, and then you'll use the computer to change data about that world somehow. So this is just an interesting thing. So the activity for this workshop is that you make a piece of artwork, and you do it using a program called P5JS. This writes JavaScript code. People will often be a little bit scared by this, but we're going to be writing this code with help from ChatGPT or Bing Chat. So what do you actually do? You create an artwork which represents a positive vision of the future relationship between humans and technology. And if you have time, it's good to write a short explanation that will really it's good to include a short write-up that explains your artwork so that you can kind of get a little description next to it. You don't always have time to do this in a workshop. And the piece that I like to focus on here is really trying to make this a positive vision. There's so many dystopian visions of technology that you see out in the world these days. You can pretty much just look at any Hollywood movie that comes out and see some kind of dystopian, dark, neon, cyberpunk corporations have taken over everything. And while that is definitely a possible future, I really like to encourage kids and to encourage teachers to think of what are the positive visions that you can think of. How do you see this relationship between humans and technology going right? What would have to change in order for it to go right? And what would that look like? So for me, this is just, oops, let's go back. This is the example that I like to give. This is something that I have made. This is I wrote this with ChatGPT, and I'm not going to go through the whole description for it, but I have a description there of what each of the pieces mean, where the human part of this are kind of the gold circles, the computer part of this are the blue squares, and then I have this relationship of data flowing between them. And if you'd like, you can pause and read. But this is the process of how I went through and actually made it. I decomposed it into pieces and realized that if I was going to do this vision that I had for an art piece, then I was going to have to break it down. And each of these pieces I actually made with ChatGPT. So now let's go into the demo. So how does this actually work? So here we'll go to the editor website for P5JS. And don't worry, there will be a link for this on the next slides. Let's just make this nice and big so people can see. So what I like doing here is just running people through what P5JS is, a little bit how it works. So there are two main pieces to P5JS here. We have the setup function and the draw function. The setup function here will run once at the beginning of the program, and then the draw function will run up to 60 times per second. So you can think of it as this is, the setup. You can create still images with this, and this will basically create frames of the video. So you can make animations. So we have the code here on the left, and then the result is going to be on the right. And if you press the play button, then you'll see that you get your resulting canvas. So what does this look like? Well, right now, not much is interesting is happening. I'm just creating this canvas that's 400 pixels wide and 400 pixels tall, and I'm giving it a gray background color. But what I might want to do is add in some more things to this. So I have a rectangle. I'm going to put it at 200, 200, and I'm going to make it 50 wide and 75 tall. There we go. I have this nice little rectangle. I might want to give it a color. So maybe I want to give it a nice blue color. So I might do something like this. And I also can add in things like variables. So maybe I want this box to be able to move. So here I'll use the keyword let to tell JavaScript I'm making a variable, and I'll say let x equal 0. Then instead of doing my rectangle with the value 200 for x, I can actually give it a variable. And you can see now it's on the left. And what I can also do is I can say x equals x plus 1. And here, what this is going to do is now you can see that every frame, it's changing my x value. Now, one thing that is weird that gets people is that in this program, y actually, the 0 starts at the top, and then it increases as it goes down the screen. So it's basically taking your normal graph that you think of and flipping it. There is some reasons why computer graphics do this. Basically, it's because computers, when they originally were used to display writing. And writing starts in the top left, and so it made more sense to start computer graphics in the top left as well. It also makes the math easier. So this is the overall process of how to do something like this. Now, you can see that if you haven't coded before, if I asked someone to do this, they wouldn't know even where to start. I like to do a demo just to show people a little bit of what's going on. But a lot of people will feel a little bit intimidated by this, and you can even let them know like it's okay if you don't understand everything that I'm doing. The point is just to show it off a little bit. Because what instead we can do is we can actually use, I'm going to use Bing Chat. So this is good because Bing Chat is at time of recording. This is the end of February 2024. A lot of schools are going through privacy impact assessments for Bing Chat, and they are actually allowed to use it in their schools. So what I might do something is I might say, write me a P5JS program, and it's important to have the P5JS keyword here. And I'm just going to move maybe okay, so write me a P5JS program where a ball bounces around the screen like the DVD logo. This is just a fun little animation to start with. And so what Copilot is going to do is it is going to then write me a thing. So I need to sign in quickly. Amazing. Okay, so let's try this again. So I'm going to say, write me a P5 JS program of a bouncing ball like the DVD loading. So the key thing here is just to say a P5JS program. Once you have that, then Bing will know what it is. Under the hood, Bing Chat is just ChatGPT. They are the same thing. Microsoft has a relationship with OpenAI, who are the creators of ChatGPT. So it's pretty much the same thing. And what I can do is I can just copy that, select all of this, hit play, and it doesn't work. So why doesn't it work? Usually, this works fine. So interestingly, this didn't work. So what I might actually do is just say, ball isn't moving. Yeah. So it looks like it forgot to actually say move the ball. Yeah, it did. Um, so let's try this again. I'm going to copy this back in. There we go. So now I have this bouncing ball. And you can have this back and forth with it for a while. You can say make two balls, something like that. You can start changing the colors. You can start adding in. All right. That's hilarious. So Bing Chat gets a little sensitive at times. And a second. No, I guess something about two balls has triggered it and triggered the safety. I think it's misinterpreting me there. So instead I said add a second ball. And let's see what it does. Okay, great. So I copy that in. Let's see if it works. Do this. Okay, now I have two of them. And so you can just keep having this back and forth. And this is what I encourage you to do as students. If you get an error, you can just give that error. You can just copy and paste that error in. I'm going to do one more. I'm going to say, make it so that every time I click the screen, another ball gets added. So this is a bit more complicated, but let's see if it can do it. Okay, so now it's going through. This time it has to do something, a little more complicated. It has to make objects and things like that. So this would actually be something that would genuinely be a little bit difficult. It requires to know some computer science concepts in order to create this, like lists and objects and what that means. And you can see that I can keep on doing this. And so this is actually pretty good. Let's do one more thing. I'll say, okay, this is, no. Then apparently I've reached this conversation limit, which is a little bit annoying. I don't know, usually it's longer than that, but that's okay. So hopefully that shows you an idea of what this activity is. And basically you're just going to do this for 30 or 40 minutes. And depending on how much time you have in the workshop, 30 or 40 minutes. And get people to experiment. There's no wrong answers here. There's so much that you can do with this little canvas. There's so many different things you can start playing. You can start making little games, little animations. And it's just a really fun little program. Okay, so let's go back. Okay, so while you're going through this, I have a slide here. So these are just the instructions. Basically, you go to the editor, you can use Bing or ChatGPT, and then down at the bottom of the screen, I have a resource that shows like some quick keywords that are helpful, like a little cheat sheet, and then the full P5JS reference. And you can see there's a lot in there. So you can really go nuts with that one. I also like to just share some keywords with people. A lot of people will start playing around with particles and fractals in particular. Flow fields are a lot of fun, but they kind of get into the tiling and noise. They're a way of putting like tiling, noise, and particles all together. That's kind of what a flow field is. And it can be a lot of fun, and ChatGPT should know what that thing is. So then I like to get people to share. If you'd like, you can even put in like a common link that people can share stuff to if you have like a Google Slides or like a Google Class. What is it? Like the Google Sticky Board. I'm forgetting its name right now. Okay, then what I like to do is, oh, we have some weird animations there, but I like to talk about the cross-curriculum connections of creative coding. I really think that this is an amazing way to bring together math, visual art, and the language arts. Because oftentimes people think math and art are just two totally separate topics. But especially when you're working with computers, everything that happens on a computer screen is math. And you, especially because you have these X and Y coordinates, you can actually start doing mathematical functions. And it's a great way to learn about functions and the different shapes of different types of functions, and like where you put brackets affects things, because it's really interactive and you get to see it. So you can see like, oh, if I put a variable inside versus outside of the brackets, or like I have an exponent or things like that, you can immediately start playing around and see these things. And it's a really wonderful way to get into math. It's also very visual art. Obviously, you have this canvas. You can start getting heavily into the design of things. You can start getting into color theory and everything like that. And secretly under the hood, it's still math. So you're still learning about all those things. And it's a really wonderful way to basically give people a creative medium. And then finally, with the advent of language models, the language arts goes into this a lot. Um, you have to get quite specific sometimes with what it is that you're asking for, and it allows you to build up your computer science skills and your technical skills at the same time as building up your language and your communication skills. Because you might have an idea for something that you want to do, but you don't know how to say it in a way that the computer understands. So you're going to have to go through this iterative conversational process with the computer, trying to be very specific and very precise with your language use, which you may have to start adding in technical computer science terms as well. So you might have to do some research on that, some research on the reference to figure out, well, what are the keywords that I have to use to get it to understand what it is that I'm trying to make. So on the computers as a medium of creation, there's so much here. Computers really are a beautiful way of expressing your creativity, everything from the kind of digital, visual art. You can create movies, music, video games are a huge one. I love teaching kids how to make their own games. This is something you can do in this activity we just went through. And just software of all kinds. I think it's really powerful to be able to start creating your own custom software, and have the ability to do that and to be able to problem solve using computers that way. And especially with language models, it makes this process easier than ever. And I'm just really excited about this. Here's just a quick bit on why we teach code again. A lot of times we're interacting with computers through visual interfaces. So whether that's using a mouse and a keyboard, or our touch screens, we're usually interacting through visual elements. Sometimes we'll have artists that interact more through a stylus, but by far the most useful and flexible tool for interacting with a computer is writing computer code. Because if you can code, you can make a computer do anything you want it to. If you stick to something like a visual interface, you're entirely reliant on other people to create ways for you to use the computer. Because even if you don't realize it, everything that you do on a computer is code under the hood. It may have a visual element to it, but every time you click on a button, everything like that, there's code running in the background. So if all you can do is interact with the visual buttons, that visual interface, you'll never be able to create your own custom functionality. So if you know how to code, then you're going to be able to create your own interfaces and your own custom functionality, and it really opens up the world. This isn't easy to do, though. There's a lot of barriers to coding. We have this term for it, even the digital divide. Part of this is physical, basically unequal access to the physical devices needed to use computers and access the internet, whether that's a laptop, a cell phone, or even just access to the internet. We've gotten a lot better at this over the last few years. Over the last decade or so, we've really increased the number of people worldwide that at least have access to a smartphone and the internet. I think it's something like close to 70-80% of the world has access to the internet on a daily basis now if they want it. And that is up a lot from even a decade ago, and it's still increasing quickly. But there's still a big barrier here with the knowledge. Coding is difficult. It can be confusing to learn. There's no two ways about it. It gets technical, it's quite unforgiving at times, and there's a good amount of elitism thrown into it, and it can just make the whole experience feel unwelcoming. Overall, the second barrier to access is resources. So it can take time and money to learn how to code, and those can both be difficult to find for people. Finally, there is the Anglo-centric world of coding. The code itself is written in English. The documentation and instructions are often written in English, and most of the tutorials are also done in English. So this can be an extra barrier to someone who does not have English as their first language. Now, things like language models, I think, make this so much easier. They really are the ultimate translation machine. It can translate between human languages. So if English isn't your first language, it can communicate into a language you do understand. It can also translate technical jargon into something more approachable. And it can take natural language and translate it into complicated computer code, which is so exciting because while it doesn't entirely remove barriers, I do think it lowers them. And particularly from the education point of view, it makes it so that teaching writing skills now not only helps with the interpersonal communication between humans, but it can assist with technical communication with computers as well. And I think this is really exciting. So overall, this workshop has gone through the ways that we can use language models to make coding more accessible and give kids and adults these accessible tools to write with. With that, this is where I'd end with questions and have the feedback form and everything like that. I hope this was helpful to anybody watching.